Hello everyone, welcome to my channel Easy Learning. In today's video, I will explain you the introduction portion of chapter 7 of grade 8, cube and cube roots. Okay, so to begin with cube and cube roots, let's first understand the terms in the chapter itself, chapter name itself. If you see, there are two terms, cube and cube roots. Like we have done the chapter square and square roots, and I told you that these are said to be the inverse operation of each other. Similarly, cube and cube roots, these two terms are said to be the inverse operation of each other, right? So the sign, if I take a variable, say x, how do we write cube? X raised to the power 3. So this is how we write the cube, and we have a symbol for the cube root as we have done for the square root, and if we write a small 3 here, then it becomes a symbol for the cube root. Okay, so if I am taking that this is the cube of x, right? So what will be the cube root of x cube? This is how we write the cube root. So if you want to calculate the cube root here, how many times I can expand x? 1 into 1 into 1, 3 times. And as in the square root, we were taking one number out from one pair. From here we will see the one triplet. So x, x and x, we can take x as out when we are calculating the cube root. So this is how the cube and cube root are said to be the inverse operation. We will understand it with one example. If I say the cube root of 2, the cube of 2 is how much? 2 into 2 into 2, right? We have to expand the base term 3 times, which gives you 8, right? On the other side, if I need to calculate the cube root of 8, what we will do? We will factorize it. So 8 can be written as 2 into 2 into 2. What will be the common now? Out of these three triplets of 2, we will take 2 as out. So the cube root of 8 is 2. So this is how cube and cube roots are inverse operation to each other. Next, we see Hardy Ramanujan number. That's a very interesting topic here. Ramanujan, we know, is the name of very famous mathematician. We have to understand Hardy Ramanujan number. So Hardy Ramanujan number we can define as the smallest number that can be expressed as a sum of two cubes in two different ways. So if any given number which you can represent as the sum of two cubes in not only one way, rather in two different ways, those numbers are said to be Hardy Ramanujan number. So let's understand it with one example. If I take the example, say 1729, right? So I have to represent it in the sum of two cubes, right? 1729, I can split it as 1728 plus 1, and this cube root 1728, it is the cube of which number? If you see, I'll show you. 1728 is a cube of 12. If you expand 12 into 12 into 12, you will get 1728. So it means here 1728 I can write it as 12 cube, and of course 1 cube is 1. So this is one way of representing 1729. Now is there any other way I can represent as 1729? Yes, if I split it as 1000 plus 729. Now we know the cube of 10 is 1000, and 729, it's a cube of 9. So I can again represent 1729 in the sum of two cubes. So it means the numbers that you can express as a sum of two cubes. So we have expressed 1729 as the sum of one and then as a sum of second cube in two different ways. It means 1729 is a Hardy Ramanujan number. Okay, so I'll be explaining you more examples. Let's take one more example, example 2. The number is 4104. Okay, so if I split it as 4096 plus 8. And this slide is very important to understand this concept. We have to split the numbers. We will see that we know that 4096, it is a cube of 16. That is how I have splitted that number according to this table. So 4096 is a cube of 16, and we know that 8 is a cube of 2. So we can write 4104 as the sum of two different numbers, sum of two cubes, right? Is there any other way I can represent it? Let's do it. There is another way of representing. If I write it as 3375 plus 729. Okay. Now this 3375, it is a cube of 15, and 729 is a cube of 9. So we have represented the given number in two different ways, in the sum of two cubes in two different ways. Hence this number is also a Hardy Ramanujan number. Okay, so I'll be taking one more example. Example 3, if I take, there is one more given in your book, 13,832. So we will also write this number in two different ways. If I split this number as 5832 plus 8000. Now 5832, again if you see this table, this is the cube of 18, right? So it means it can be 18 cube, and we know this is 20 cube. On the other side, if I split it as 13824 plus 8. So this is the cube of which number? This is the cube of 24, and 8 is a cube of 2. So again we have splitted the given number in two different ways as the sum of two cubes. Hence it is again a Hardy Ramanujan number. So this is how, if you can express, as you see the definition carefully, the smallest number that can be expressed as a sum of two cubes in two different ways, not only in one way. You should be able to express the given number in two different ways, then only it is said to be the Hardy Ramanujan number. Okay. Now, so this is one quick slide where we have calculated the cubes of the number. This is a very good idea, if you can remember the cubes till 20. So this is basically 1 cube means you are expanding 1 3 times, because the base is 1 and the power or the exponent is 3. So 1 into 1 into 1 is 1. Similarly 2 cube, base is 2 here and the power is 3 or the exponent is 3. So we have to expand the base term how many times? 3 times. So 2 into 2 into 2, which gives you 8. 3 cube means 27, 4 cube 64, 5 cube 125, and so on. Now the idea of showing you this table is, if you observe, cubes of even numbers is always even, and cubes of odd numbers are always odd numbers. So let's see it. If you see 4 cube, 4 is an even number and its cube is also an even number, right? If I see 9 is an odd number and its cube is also a odd number. 14 is an even number, its cube, the unit place digit is 4, it means it is also an even number. 17 is an odd number, unit place digit is 3, it means 4913 is also an odd number. So we can conclude that cubes of even number is always even and cubes of odd number is always an odd number. Okay. So the next topic is adding consecutive odd numbers. So we will observe a pattern here. Okay. If you see, if I write suppose 1, it gives me 1. The next consecutive odd numbers after 1 is 3 and 5, right? So next two numbers when I am adding, its sum comes out to be 8, and 8 is a cube of 2, right? If I add next three consecutive numbers, what are three next consecutive numbers after 5? It is of course 7 plus 9 plus 9 plus 11. 11 plus 9 gives you 20, and this gives you 27, which is a cube of 3. So you see, you are getting a pattern. When you have added one odd consecutive number, that gives you a cube of 1. Next two consecutive number, their sum gives you a cube of 2. When you are adding next three consecutive number, which is 27, gives a cube of 3. If I further go, right after 11, the next number is 13 plus 15 plus 17 plus 19, which is 64, and 64 of course is a cube of 4. 4 fours are 16 and 16 fours are 64. So this is a quite interesting pattern you can observe. I'll write one more. After 19, next odd consecutive is 21, then 23, then 25, 27 and 29. So if you take the sum, it gives you how much? 125, and of course it's a cube of 5. So we are observing a pattern here when you keep adding the odd consecutive numbers. So you have added two numbers, it's a cube of 2. When you have added three odd consecutive number, next after 5 you are getting a cube of 3. Here 1, 2, 3, 4, a cube of 4. The next 1, 2, 3, 4, 5, 125, and which is a cube of 5. So this is something, an interesting pattern we can observe from the sum of odd numbers. Okay, let's move further. Now I will explain you the questions with certain examples. The first question which you see on the screen is 243 a perfect cube? So how we will check whether the given number is a perfect cube number or not? So there is only one method, the prime factorization method. As in square and square root chapter, we have done so many methods to calculate. Here in cube and cube root method, we have only focused on prime factorization method, and the second method which you will be understanding is the estimation method to calculate the cube roots of given number. Okay, so is 243 a perfect cube number? So first thing what we will start with, we will calculate the prime factorizations of the given number. So 2 plus 4, 6 plus 3, 9. It means this is divisible by 3. 3 8s are 24 and 3 1s are 1. Again 3 2s are 6 and a 2 is left, which gives you 3 7s are. Again 3 9s are 27 and then 3 3s are 1 and a 3 3s are 1. So if I make the pair of 3, this is a complete triplet of 3, but this is not forming a triplet of 3, right? So what can be my reason? Whether the question is it a perfect cube? So my answer to the question is, given number is not a perfect cube, right? Why it is not a perfect cube? Because 243, when you are writing the factors, will be like this. Okay, so you can underline, this is forming a triplet, but there is 1 3 into 3 which is not forming a perfect triplet, hence the given number is not a perfect cube. So when the question comes whether this given number is a perfect cube or not, so we will do the prime factorization, we will make triplets, and if there is any number which is not forming a perfect triplet, the given number is not a perfect cube. Okay, let's see next example. Now find the smallest natural number by which 392 must be multiplied. So there will be two type of questions, must be multiplied and must be divided to make it a perfect cube number. It means 392 is not a perfect cube number, and you have to calculate by what number you will multiply 392 so that the given number becomes a perfect cube number. Okay, so again with the same method, the first thing we will start with the prime factorization of 392. Okay, so let's start. It is divisible by 2. 2 1s are 2, a 1 is left, 2 9s are 18 and 2 6 are 12, right? Again 2 9s are 18 and 2 8s are 16. Then you get 2 4s are 8, 2 9s are 18. Now 49, it is divisible by a 7. So 7 7s are 49 and a 7 7s are 1, right? So we can write that the prime factorization, the prime factors of 392 are 2 into 2 into 2 and a 7 into a 7, right? So if you observe the pattern, I am getting a perfect triplet of 2, but I am getting 7 into 7, means it's not a perfect triplet of 7. So what can I do? The question is by what number you will multiply to make it a perfect cube. So it means if I multiply by 7 here, then I will get a perfect triplet of 7 as well. So This side also I have to multiply the given number by 7 to make it a perfect cube number, right? So if you multiply it, what it will be? 7 2s are 14, 7 63 and 7 3s are 21, plus this gives you 2744. So 2744, right? What will be its cube root? 2 into 7, which will be 14. So what will be your answer? Find the smallest natural number. So the smallest natural number is what? Is 7, right? The smallest number is 7 uh, to be multiplied with 392 to make it a perfect cube. Okay, so this is the case when the question was by what number you will multiply. On the other side, if I give you the question by what number you will divide with it. So you see I am taking the same example 392. Now you have to calculate by what number you will divide with. So without repeating the prime factors of 392, we have just calculated as 2 into 2 into 2 and 7 into 7, right? So let's write the factors as 2 into 2 into 2 and then 7 into 7. So basically, if you see here carefully, I am getting a triplet of 2, but this is not forming. It means this 7 into 7 is extra. It means I have to divide 392 by 7 into 7 to make it a perfect cube number. So what we will do, we will divide both the sides by what number? We will divide both the sides by 7 by 7, so that this is cancelled. So how much you are getting here? 392 by 49 is equals to 2 into 2 into 2. If you divide 49 into 8 is 392. Okay, so how many times it is going? 49 into 8. So it is going 8 times, and you see the perfect cube is 8. So what we have done, we have divided by 49 on both the sides to make the given number a perfect cube number, right? So how will you write the smallest natural number is 49, by which 392 must be divided to make it a perfect cube. So if you have to multiply, like in the previous question, if you have to multiply means whatever is left, here you were saying that it is a perfect triplet, here it was 7 into 7, you need another 7. So we have multiplied on both sides by 7. By what number you will be dividing it to make it a perfect? So whatever are the unpaired means which are not making perfect triplet, you have to divide with those numbers on both the sides and you will get a perfect cube number. Okay. So now the last topic which I am going to explain you in the introduction portion is finding cube root using estimation method. That's a very interesting topic and a very short way to calculate the cube root of the given number. But you see I have written here that this method can be used only if the given numbers are perfect cube number. Then only we can make use of this method. Okay. So you see how do we calculate it? The first method to calculate it of course is the prime factorization method, but now this method is named as estimation method to calculate the perfect cube of the numbers. So how to go with this? The number is 4, 9, 1 and 3, means 4913. We start making group of 3 digits from the right hand side. So the first group and this is your second group. Okay, so this is your first group and this is your second group. We will start making the groups of 3 digits starting from the extreme right, and I am getting here 2 groups, the first group and second group. Now first we will start with the first group. What is your first group? Is 913. What is unit digit in 913? It is 3, right? Then we will calculate cube of 3, means 3 cube, 3 3s are 9 and 9 3s are 27. What is the unit place digit you are getting here? What is your unit place digit you are getting here as 7. Okay, so it means when I will write the cube root of 4913, the unit place digit will be 7. Now we will calculate the tens digit. I am again repeating how we have calculated the unit place digit. First, start making the pairs, start making the group of 3 digits starting from the extreme right. This named is at first group, then second group. Now the first group, you have to see the unit place digit, which is a 3 here. Take the cube of that digit, and the unit digit in the cube of number will define the unit position of the cube root of given number. Now we will see the second group. Second group is what? Second group is only a 4. You will see that 4 lies between the cubes of which two numbers, right? See, the cube of 1 is 1, the cube of 2 is 8, and the cube of 3 becomes 9, right? So if I see carefully, 4 lies between 1 and 8. It means I can write that 4 lies between the cube of 1 and 2 cube, right? 4 lies between the cube of 1 and 2. So what is smaller number here? Of course, 1 is smaller than 2. So this 1 here, whatever number will be smaller on the left side will be your tens place digit in the cube root of given number. Therefore, the cube root of 4913 is 17. I am again repeating the second step. Second group was your only 4. You will see that this 4 lies between the cubes of which two numbers. So we will start writing. 1 cube is 1, 2 cube is 8, but 3 cube is 9. But 4 lies between 1 and 8. It means between the cube of 1 and 2. So we have written it here. 1 cube is less than 4 and 4 is less than 2 cube. We will take the smaller number between these two. Smaller is 1, that defines the tens place digit in the cube root of the given number. So is it a simple method, a very shortcut method to calculate the cube root of given number using estimation method? But the important thing here, this method can be used for perfect cube numbers only. If the questions are what you will multiply with, what you will divide with to make a given number perfect cube number, we cannot use these methods. Okay. So this was the introduction of this chapter. Please do watch my next video for the solution of next exercise. Till then, bye bye, take care.